Good morning to everyone. Myself Kailash Kumar. Welcome to my YouTube channel. Today we are starting a new topic, Compiler Designer. First we will see what is Compiler Designer. Introduction to Compiler Designer. Compiler design is a fundamental concept in automata theory and computer science. It involves various phases, each crucial in converting high level programming language into executable machine code. Let's move to next slide. Linux analyze phase. Tokenizations, elimination of white space, error handling. There are three Linux analysis phases. First is tokenization, the process of breaking into tokens such as a keyword, identifier, and the constant. Elimination of white spaces, removal of unnecessary space, tab and line breaks for a source code. Error handling, identification and report of Linux error found in the source code. Let's move to the next slide. Syntax analyze phases. In syntax analyze phases, we have three types: phaser generation, abstract static teacher, error recover. Phaser generation. First, we will see creation of phrases for a specific grammar rule and construction a tree representation of a source code syntax structure in the abstract syntax tree. Now, error recover method to handle and recover the for syntax error. Let's move to the next slide. Semantic analyze phases. There are three type checking, symbol table construction, error checking. First type checking, verification of correctness of an operator used on different data type. Now symbol table construction, creation of a data structure to store information about the variable in the source to the source code. Now error checking, dedications and reporting of semantic error and discrimination in the code. Let's move to the next slide. Intermediate code generation phases. Code transformation, algorithm optimizing, function leaning. Now conservation of source code into a intermediate representation, application of specific algorithm to optimize the intermediate code, replacing the function call with the function code to enhance performance. Let's move to the next slide. Code optimizer phases. There are three types of code optimizer phases: 1, 2, 3. First, constant flooding, loop optimizing register allocation. Now, constant flooding, evaluating constant expression at a compile time to save execution time. Loop optimization, restriction loop to improve the execution speed and reduce the time complexity. Now registration allocation, mapping variable to hardware register for efficient use of resources. In this we have these three types: constant flooding, loop optimizing, and register for, allocation. Let's move to the next slide. Code generation phases. We have code generation phases in Compiler Designer. There in these three we have three types: instruction selection, assembling, output generation. First we will see instruction selection, choosing instruction that closely analyze with the architecture of a target machine. Assembling, now we will see assembling, conversion of an intermediate code into a machine code through an assembler. Output generation, creation of an executable file that the machine code and the additional metadata can be formed. Let's move to the next slide. Now we will see conclusion and the summary of a compiler designer. Now what we have teach we will learn in this. Now we will see what is in this. Compiler design is a multi-phase process that accomplishes Linux syntax, semantic analysis, intermediate code generation, optimization, and the code generation phase. And in this, we will see the Linux syntax, semantic analysis, intermediate code generation, and optimizing, and the code generation phase. Understanding these phases is crucial for mastering that complexity of a transition source code into executed program. Thank you. Have a nice day.